Good morning, students. Computer network. Okay. So the previous class we have seen the period and frequency. So the frequency is the rate of change with respect to time. Changes in a short span of time means that high frequency. Change over a long span of time means it is a low frequency. High frequency. Short span of time, it is a high frequency, and long span of time is a low frequency. If a signal does not changes at all, then its frequency is a 0. If a signal changes, then its frequency is a infinite. Now, what is a phase? Third component is a phase. The phase describes the position of the waveform relative to time 0. It is measured in degree or radian. Okay. That is 360 degree equal to 2 pi radian. Therefore, 1 degree equal to 2 pi divided by 360 radian. So here 3 sine waves with the same amplitude and frequency but different phases. Okay. So 0 degree here, then 90 degree. So the 90 degree. So this is the 90 degree, and then the 180 degree. So this is the 180 degree. So these are the 3 sine waves with the same amplitude and frequency but different phases. Let us say an example. A sine wave is offset 1/6 cycle with respect to time 0. What is its phase in degree and radian? Okay. So one complete cycle is a 360 degree. Okay. One complete cycle. One complete cycle is a 360 degree. Therefore, 1/6 cycle is 1/6 into 360. So 6 times, therefore 60. So we want to convert into radian. Therefore 60 into 2/360 radian. So 6 times 2/6 is 1/3. Therefore pi/3 radian. So 3.14. Pi value is 3.14 divided by 3. Therefore 1.046 radian. So the phase can be calculated using this one. Okay. The next step, wavelength. The wavelength can be calculated if one is given the propagation speed and the period of the signal. Okay. That is the wavelength equal to propagation speed into period. Suppose if it is a frequency means 1/frequency. That is a propagation speed divided by frequency. What is called a wavelength. Right? So this is the transmission medium. Then at time t, the wavelength. At time t plus t. So this is the wavelength. And this one is the time domain and the frequency domain plots of the sine wave. Okay, here a sine wave in time domain whose peak value is 5 volt and the frequency is here 6 hertz. So amplitude time. Then so peak value is here 5 volt and the frequency is here 6 hertz. Okay. So a complete sine wave in time domain can be represented by one single spike in the frequency domain. Okay. Here, so 6 and peak value is here 5. So discrete value. This one is here continuous one. Here, the example of the time domain and frequency domain of 3 sine waves. Okay. So this is the one sine wave at volt 5, and then 15. Sorry, 10. This is here 10. Like that here. So 5, 10, 15. With the frequency 0, 8 and 16. So 8, 0, 8 and 16. The next, so what is a composite signal? So far we have seen the simple signal. Okay, now composite. A composite signal is made up of many simple sine waves. Again, it is a periodic and non-periodic. If the composite signal is periodic, then decomposition gives a series of signal with discrete frequencies. Okay. So if it is a non-periodic, then decomposition gives a combination of sine wave with continuous frequencies. So under periodic, it is a discrete, and non-periodic, it is continuous one. So this is a composite periodic signal. So multiple sine waves. So this is the decomposition of composite periodic signal, the time and the frequency domain. So for frequency F, so this is for the frequency F, and this is for frequency 3F. So for composite, and then frequency 9F. This is indicates the frequency 9F. Okay. So in the non-periodic, frequency F here, frequency 3F and frequency 9F. Another example is the time and the frequency domain of non-periodic signal. So this is the time domain, and this one is a frequency domain for 4 kilohertz. The next, bandwidth. That is, the bandwidth is a difference between the highest and lowest frequency of a signal. The bandwidth of a composite signal is a difference between the highest and lowest frequency contained in a signal. Let us see an example. Suppose that if a composite signal contains the frequency between 1000 and 5000. So 5000 is a highest frequency and 1000 is the lowest frequency. Therefore, the bandwidth is a difference between highest and lowest. Therefore, 5000 minus 1000, which is equivalent to 4000. So So here example. So bandwidth of a periodic and a non-periodic composite signal. So 1000, 1001 like that, etc. Then end with 5000. Therefore, this is the bandwidth. So highest frequency 5000 minus lowest frequency is here 1000. So which is equivalent to 4000 hertz. Then non-periodic. Okay. So 1000 continuous one. This one is a continuous one. So bandwidth equal to 5000 minus 1000 equal to 4000 hertz. Okay. Let us see some problems. If a periodic signal is decomposed into 5 sine waves with frequencies of 100, 300, 500, 700 and 900 hertz, what is the bandwidth? And draw the spectrum assuming all components have a maximum amplitude of 10 volt. Okay, let us learn. So FH be the highest frequency and FL denotes the lowest frequency and V denotes the bandwidth. Then the formula is bandwidth equal to highest frequency minus lowest frequency. So highest frequency is here 900 and the lowest frequency is here 100. Therefore 900 minus 100 equal to 800 hertz. The next we have to draw the spectrum diagram. Then assume that the amplitude is here 10 volt. So this is the spectrum diagram. Lowest is here 100, then the voltage is a constant 10 volt, then 100, 300, 500, then 700 and 900. Okay. Then bandwidth equal to highest minus lowest, that is 800 hertz. So like that we can draw a spectrum diagram for a particular bandwidth. In another example, a periodic signal has a bandwidth of 20 hertz. So here V is given, bandwidth is given. The highest frequency is here 60 hertz. Therefore, FH equal to 60. So what is the lowest frequency? And then draw the spectrum. The signal contains all frequencies of the same amplitude. Okay, here FH be the highest frequency and FL be the lowest frequency and V be the bandwidth. Therefore, the bandwidth equal to FH minus FL. Okay, what is FH? FH equal to 60. Highest frequency. Lowest is not given. Okay, therefore, F1 equal to bandwidth minus FH minus bandwidth. Okay, so where FH equal to 60 and bandwidth equal to 20. Yes, therefore 60 minus 20 equal to 40 hertz. So this is the lowest frequency. So like that, if lowest frequency is given, then we can also calculate the highest frequency. So this is the spectrum diagram. So what is the lowest frequency is here 40 and the highest frequency is here 60. Therefore, we have to, the voltage is a constant and hence 41, 42, etc. Then this is the 60. Therefore, the bandwidth equal to highest frequency minus the lowest frequency. So 20 hertz. So this is another example. A non-periodic composite signal has a bandwidth of 20 kilohertz with a middle frequency is given, so 140 kilohertz, and a peak amplitude of 20 volt. The two extreme frequencies have an amplitude of 0. Draw the frequency domain of the signal. Okay, here, so bandwidth is given. Bandwidth is here 200 and middle is here 140. Okay, so middle is 140. So bandwidth is 200 means it is bandwidth is a difference between highest minus lowest. Okay, that means we divide this one 100. Therefore, middle is a 140 means the highest is a 140 plus 100, which is 240. And the lowest is a from middle 140 minus 100, so it is a 40. Therefore, from 40, then voltage level, and then the highest frequency. So this is the spectrum diagram. Composites. Okay. Okay, thank you, students.